All right, so we are now on to lesson number, I believe it's 4, stoichiometry and the different types. And the first type that we're going to be looking at is mass stoichiometry. Now, whenever we are going to use mass stoichiometry, all that means, guys, is that we are going to be using mass to find moles or moles to find mass, okay? Now, again, because this is stoichiometry, there are two requirements. First requirement is a balanced chemical equation. So let's look at what this example is asking. This example says, what mass of oxygen must be available to burn 120 grams of ethane, okay? It doesn't give you an equation, you have to develop it. But there is a key word, and that key word is burn. Burn, okay, not burn in grade 12. Burn equals combustion, okay? So right away, I know that I'm going to be writing a combustion reaction, okay? So combustion reactions are fuel, which in this case is ethane, C2H6, and I believe it says it's a gas. I'm reacting that with oxygen, gas, O2, okay, it's diatomic, and I'm always producing in combustion carbon dioxide and water vapor. Always, 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 okay? So I have my equation, but it is not balanced, okay? Like we talked about last week, the first thing that you should always try balancing is the carbons, okay? There are 2 carbons on the left side right here, and there's 1 carbon here, so all I have to do is add a 2. Then we go hydrogen, there are 6 here, there's 2 here, so I need to multiply that by 3. Now I have 2 times 2 is 4, plus 3 is 7. Well, I have 2 here. What am I going to do? I'm going to go 7 over 2. Because 7 over 2 times 2 equals 7. Okay, so remember that from last week. So I have a balanced chemical equation right now. Okay. The second requirement that I need is the moles of one chemical. Well, it doesn't give me the moles of something, it gives me the mass. It says 120 grams of ethane. So all I'm going to do is underneath ethane, I'm going to write the mass. Now, alarm bells should start to go off. The second requirement says we need the moles of something. I gave you the mass. Is there a way to go from from mass to moles? Yes. To go from mass to moles, what I need is I need N, which is moles, equals mass divided by molar mass, okay? So that means I have mass, great. I need the molar mass, okay? I need the molar mass of ethane because that's the chemical I'm talking about. If I look in my data booklet at my periodic table, I can determine the molar mass, okay? I got 12.01 times 2, that's carbon, plus 6 times 1.01, plus, not times. And that's going to give me 30.08 grams per mole. Okay? So all I'm going to do now, guys, to find the moles is sub in those numbers. 120 grams divided by 30.08 grams per mole. So I do 120 divided by that, and 120 divided by 30.08 gives me 3.9893 ... moles. Okay, I'm going to put a box around that, but it is not my final answer. That's why I have the ... I'm not going to round that number. I'm going to keep it in my calculator. Okay, now here's the thing. Stoichiometry problems say that we need 2 things. Balanced chemical equation, check. The moles of one chemical, check. Now we can ride the molar coaster. In this question, it's asking us to figure out the mass of oxygen. Well, if I want to figure out the mass of oxygen, if I just look at this equation, I need moles, molar mass. Molar mass, easy. Periodic table. What about moles? To figure out the moles of something you do not know, you have to use the molar coaster and something we do know. Okay? Now, the molar coaster is I divide by where I start and I multiply by where I'm going. So I divide by where I start. The coefficient here is 1. So I divide by 1. And then I multiply by the coefficient of where I'm going, which is 7/2. Okay. So take your moles, divide by 1, stays the same, and then multiply by bracket 7/2. You will end up, if you do this, with the moles of oxygen, which are 13.9627 ... moles. Okay? These are the moles of oxygen. Now, the question didn't say, what are the moles of oxygen? It said, what is the mass of oxygen? Okay? So to figure out what the mass is, guys, I need to do moles times molar mass. Okay, well, that's easy. I've got the moles, 13.9627, but I don't have the molar mass. What's the molar mass of O2? Okay, well, each oxygen gives me 16, and there's 2 of them, so I'm going to write 32.0 grams per mole. Do I ever use the coefficient to find the molar mass? No, I will fight you. Okay, never use the coefficient to find the molar mass. It's just the chemical. So going back down here, I'm going to sub that in for molar mass, 32.0 grams per mole. So my mass is my unrounded moles times 32.0, which is 446.808 ... grams, because the moles have canceled out. And here the grams cancel out. Okay, now how many sig digs are in my answer? If I look back at what was given, there's 3. So the final answer for the mass of oxygen that is used up, ladies and gentlemen, is 447 grams. We round that up. Okay, so again, requirements, balanced chemical equation, and the moles. Because I didn't give you the moles, I gave you the mass, but you're like, oh, that's easy. I can find the moles from the mass using this equation. I can then ride my molar coaster to figure out the moles of a different chemical, and then use the same formula to find the mass of that chemical. This, ladies and gentlemen, is the molar coaster.